Okay, so let's dive in. Probably the biggest question out there, the one everyone wonders about, are we alone?
It's fundamental.
And for this deep dive, we're really trying to get past the movies and the fiction.
Yeah.
We're looking at the science based on the sources you provided. What do we actually know?
And, well, the absolute starting point, the non-negotiable scientific baseline right now, is that we have no concrete proof. Zero. No verifiable evidence of extraterrestrial life.
So lots of searching, but finding. Nothing confirmed.
Exactly. The search is active, very active, but the results column for confirmed alien life is empty.
But the reason we keep looking, I mean, it's the sheer scale, right? The numbers are just wild.
Oh, astronomical doesn't even cover it.
Our sources point out, billions of stars right here in the Milky Way.
Billions. And most seem to have planets.
So you multiply that out?
Yeah.
Billions of galaxies, too.
Yeah.
You're talking trillions, maybe, of potential spots for life.
Trillions upon trillions of potential habitats. It makes the possibility seem almost, well, inevitable to some.
And we know SETI's out there, right? The search for extraterrestrial intelligence. They're listening.
They are actively scanning the skies. They're looking for signals that aren't natural artificial radio waves, something indicating technology.
And the results so far?
Just silence, essentially. Cosmic static. Nothing that says hello.
Okay, so if the universe is this massive haystack, where are scientists actually focusing their search? Where are the tangible targets?
Well, they often start closer to home, actually, right here in our solar system.
Makes sense.
We look for places where the conditions might be right or were right, especially the presence of liquid water.
So Mars obviously comes up. People have talked about Mars forever.
Right. Mars definitely had liquid water billions of years ago, so the thinking is maybe microbial life got started back then.
But the water's gone now, mostly.
On the surface, yes. But then you look further out at the moons of the gas giants. That's where things get really interesting.
Okay, like Jupiter's moon, Europa.
Exactly. Europa is fascinating. It's covered in ice, but scientists are pretty convinced there's a huge saltwater ocean underneath, miles down.
How could it stay liquid way out there? It's freezing.
It's Jupiter. The sheer gravity pulling and squeezing Europa creates friction inside the moon. It's called tidal heating.
Ah, right. Like kneading dough, it warms it up.
Sort of, yeah.
Yeah.
Enough to keep that massive ocean liquid. And the ice shell protects it from radiation.
And then there's Saturn's moon, Enceladus. The sources seemed really keen on that one.
Enceladus is maybe even more exciting in some ways, because we don't just think there's water, we see it.
We see water. How?
It's shooting geysers. Huge plumes of water vapor, ice particles, even organic molecules erupting from cracks in the ice near its south pole.
Wow, so it's basically sending samples out into space for us.
Pretty much. It suggests a warm internal ocean, and we could potentially analyze its composition without even needing to land and drill. That's a huge advantage.
Okay, so that's our neighborhood. What about outside the solar system? Exoplanets.
Right, the hunt for exoplanets is massive now. We're looking for planets orbiting other stars, specifically in the Goldilocks zone.
The habitable zone. Not too hot, not too cold.
Exactly, where temperatures could allow liquid water to exist on the planet's surface.
How do we even find these planets? They're so far away.
One of the main ways is the transit method. We watch a star very closely, and if a planet passes in front of it from our point of view,
The star's light dims just a tiny bit.
just a tiny, tiny bit, but we can detect that dip. It tells us a planet is there, how big it is, how close it orbits its star. It gives us clues about habitability.
So if we did find life, whether nearby or far away, what would it look like? Forget the little green men.
Yeah, the popular image, big head, large eyes, that's entirely shaped by our evolution and imagination.
It depends on their world.
Completely. High gravity world, maybe life is short, stocky, dense, low light. Huge eyes might be common. A water world, maybe something fish-like. Evolution is the driver.
But it could be even stranger than that, couldn't it?
Oh, absolutely. This is where it gets really mind-bending. Life might not just look different. It might be fundamentally different chemically.
What do you mean?
We're carbon-based life. We use water as a solvent. But what if life somewhere else evolved using silicon as its base?
Yeah.
Or maybe methane instead of water?
So it could be bacteria-like, but just weird bacteria.
It could be that simple, yes. Or it could be so radically different in its structure and chemistry that we might stare right at it and not even recognize it as life.
Which kind of brings us to sightings here on Earth, right? The whole UFO thing.
Right. And the term has shifted, importantly, from UFO to UAP.
Unidentified anomalous phenomena.
Yes. And the key word there is unidentified. It means just that. We don't know what it is.
The sources are clear, though. Governments, pilots, they have seen things they can't explain. Objects doing things our planes can't.
That's acknowledged, yes. There are documented cases of trained observers witnessing phenomena that defy conventional explanation. Military pilots, radar operators.
But, and this is the crucial point from all the official reports, unidentified does not mean alien.
Absolutely a critical distinction. It could be advanced drones, secret military tech, atmospheric phenomena, sensor glitches, optical illusions, many possibilities before jumping to extraterrestrial craft.
So no government, no scientific body has ever presented actual proof that any UAP or UFO was an alien spaceship.
Correct. Despite the reports of unexplained sightings, there's never been verifiable concrete evidence like wreckage or confirmed alien technology presented by any official institution.
Okay, so pulling it all together, where does that leave us?
Well, it leaves us with probabilities versus proof. The sheer scale of the universe makes the probability of life elsewhere seem very high, almost a statistical likelihood for many scientists.
Wow.
But the actual verifiable proof remains completely elusive. We haven't found that unambiguous signal from SETI or that alien microbe on Mars or Enceladus. It's still firmly in the realm of hypothesis.
So the biggest question,
Yeah.
still unanswered.
For now, yes.
Which leaves you, our listener, with this final thought to chew on. If life on another world isn't just different looking, but based on a completely alien chemistry, something not using DNA or proteins like us, how would we even know? Could we develop the right tests? Would our instruments even register it if we scooped up a sample? Finding a life might not be about spotting spaceships, but about recognizing something profoundly weird, maybe even right under a microscope.